Thank you for joining us for today's IBM Community Webinar. Our topic for today is Cloud Native Adoption, the Broader Picture. My name is Jess Leitch, and I'll be your host for today. With that, I would like to introduce our experts for today. We have Kyle Brown joining us, who is an IBM Fellow and the CTO of Cloud Architectures for IBM Cloud in Cognitive Software. With him, we have Kim Clark, who's an Integration Architect and Strategist. Welcome, gentlemen.
Let's get started. Thanks, everyone, for attending. Let me tell you a little bit about what started this project and how Kim and I got going with this. What happened was that Kim and I were talking, as we often do, and we realized we had some common experiences. And in particular, what had happened is that we had been speaking with multiple different clients. Kim had spoken with a group, I had spoken with a different group. And we found out that we were seeing the same thing, in that what was happening is when we were talking to clients about building cloud native systems or refactoring to cloud native systems, the very term cloud native sometimes got a little contentious and often a little fuzzy, because what happened is people would jump directly to technology issues when they're starting to talk about cloud native. And while technology is absolutely a critical part of cloud native development, it's not all of cloud native development. And Kim and I kept finding that we were having to walk people back and kind of look at the bigger picture of what cloud native really encompasses and what it means. So if you want to kind of walk through the way that we were originally thinking about things, we were starting to help our clients to step back and look at the broader view of why we're doing cloud native development and cloud native refactoring and cloud native deployment to begin with. And it really comes back to, there were a set of goals and a set of outcomes that we were trying to achieve in those clients. You know, when they start using words like cloud native, we could start asking them some questions about, well, what do you really want to achieve on the business side? And we'd often hear very common things like, well, we want to improve our market share, or we want to grow within our particular industry segment. We'd hear things like, well, we want to actually mitigate the amount of risk we have, because it seems like every release we have, it's really risky and things can go wrong very badly, and it takes a long time to get to our releases currently. Or they may simply just want to have a cost discussion and say, well, we want to move to cloud native because what we're doing now on mainframe or on distributed is just too expensive, and we want to reduce our costs. That's fine. Those are all great discussions to have, and they may lead you to cloud native. Often, though, the way this would play out is that there would be a corresponding set of IT goals that would, in some sense, map to those business goals. See, for getting to the point of having market growth, it really means being able to better deliver new features that your customers want to those customers faster, more quickly than your competition. That means you have to improve your agility and your productivity to be able to deliver those features faster and more effectively. To reduce risk, it really means we're talking about how do we make sure that we can deal with the situation where all of a sudden one of our products or one of our features explodes and people all want to use it. So we have to be able to take advantage of cloud native scalability, or at least cloud native resilience if something goes wrong in the cloud, which happens all the time. But then there's this other discussion around cost. And what that comes down to is being able to make sure we have a framework for being able to be more efficient and to optimize how you're using the resources, both of your team and of the cloud itself. That's kind of the broader perspective. And as we started thinking about this, we realized you really have to combine three different areas to make sense out of this. What we always want to focus on is the infrastructure and technology issues. People will always start a cloud native discussion by saying, well, I want to do cloud native. That means I'm going to have to move to AWS and use Elastic Beanstalk, right? Well, maybe that's part of the discussion, but that's not what cloud native means. It also means you have to think about doing your architecture and design in such a way that you can take advantage of these kinds of features provided by the cloud providers. But it more importantly means you have to change your processes and you have to give your people the right skills and the right opportunities to be able to take advantage of these new architectural approaches and these new pieces of technology that the cloud providers and other technology providers can give you. So that was kind of the bigger picture that we were looking at. Now, as we started thinking about that, that means that our definition of cloud native means you are doing all of these things. You're putting together the right processes, the right architectures, and the right technology to fully leverage what it is that makes cloud unique. That means you're going to achieve all of these different goals we were talking about of agility and resilience and optimization by being able to take advantage of enabling rapid innovation guided by real numbers, real business metrics, of being able to target continuous availability in a way that's going to be self-healing and then will result in lower or reduced downtime. And then finally, to be able to optimize the cost of your infrastructure at a global level, but also optimize the way that your people are being applied so that people are always adding to the overall business value of this approach. That's what cloud native really means, is trying to achieve all of these by linking all three of these areas together. Now, what happened is, as we started thinking about this overall kind of conversation starter of the way that we, now want to get our clients into understanding what this means, we realized something. And that is, if you start to break this all apart, each of the different pieces correspond to different aspects of what we were just talking about. The people and process aspect is really the one that's linked to both autonomy and agility of your teams. It's being able to make your teams more effective in what they do so they can deliver smaller results more quickly and more effectively. It's also giving you the right architectural approaches so that you have solutions that leverage the uniqueness of the cloud infrastructure. The things like scalability through things like auto-scaling, or the ability to very quickly turn things on and off, or the ability to essentially leave some of the decisions around management to the cloud provider itself. Well, these are the ways that you take advantage of the cloud provider platform or the other technology platforms to abstract away all of the complexities of management that we've been doing for the last 30 years into a more effective way of managing it as a single unified platform. Well, what happens is that once we started exploding that through, we started realizing that it kind of helps us understand how to look at what cloud native means by breaking even the term cloud native apart. See, for us, cloud really refers to that technology platform. It's an abstracted infrastructure platform where we've taken a step away and we're not considering a particular cloud provider. We're trying to say what it is that joins all the cloud providers and all of the on-prem technology providers, like wonderful platforms like OpenShift, together and give you this ability to be able to be self-provisioning, have elastic expansion of your applications, but also importantly have this idea of automated recovery. That gives you a way to deal with all of these pieces in such a way that you can have immutable deployments, be declarative in the way you provision things, but also be agnostic to kind of some of the technology details of the runtimes. So if that's what we mean by cloud, that we're being very specific on those attributes, then what does native actually mean for us? Well, native means you have to be able to take advantage of those pieces. You're getting to having an architecture and design of your solution that allows you to be able to deal with immutable deployments and declarative provisioning. That means you're going to have less state. In fact, no state would be the best, although we almost never achieve that. It means you are going to have to build your system as components that are very lightweight and are essentially disposable. You've all heard of the idea of cattle rather than pets. That's what we're trying to get to, is things that essentially can go away very quickly and be replaced by the next version or by another version if the system fails. But to do that, architecturally, you have to go back to the idea of very well-defined interfaces. That's one of the critical keys in making sure that you're decomposing your system design such that it's built out of these very well-defined pieces with well-defined interfaces and very clearly understood abstractions. One of the things we do end up having to talk about is, notice that at no point did we refer to a specific use of a cloud provider tool or cloud provider service. We often hear people say, well, yes, we're running on Amazon, we're cloud native. That's not what it means. You still have to architect your system to take advantage of the unique pieces that a cloud provider like IBM Cloud or AWS or Azure provide to be able to really be fully cloud native. If you just are taking advantage of things, but like, let's say, AWS VMs, but you're still doing all your processes and all your architecture the old way, well, at best, you're cloud provider network native, but you're not cloud native in the way we mean. It's more of a transformation. And that really gets to what it takes to bring this all together. You have to change the way your processes work, and you have to make sure your people have the right skills to be able to make this effective. You've got to make sure that they're able to collaborate and that your processes are going to allow you to achieve this kind of agile feedback loop that we've been talking about. So as we started looking at this, we realized as you break down each of these pieces and you start talking about, well, what it makes up people and process, what makes up architecture and design, and what makes up technology and infrastructure, it breaks down in this way. And these are all the things that we've been talking about in the last few slides as we've talked about all the great things that go into being cloud native. Well, then we thought about it a little bit more. And we realized that you could group them in a slightly different way that may help you be able to take advantage of how to do your team organization and how to really pick up these things a few at a time. And in fact, what we realized is that if you group them in this way, now we're still going down the same set of things we were talking about, you can begin with a set of initial concepts around essentially putting together a microservices architecture and then putting that microservices architecture on top of a container infrastructure. What you can then do is you can move on to, once you've begun that process, now you have to really achieve agility through better automation. That's being able to take advantage of agile methods by having the right DevOps infrastructure, by having the right lifecycle automation and operational automation to make those faster cycles possible. And then that's going to then allow you to expand out to become more sustainably empowered in your teams, because often that's where you run into issues with process and organization, is really giving teams the autonomy that they need, making sure that you are secured by default, which is, again, a process change because it means changing your organizational structure and changing the responsibilities of people in your team. And then finally, really thinking about things from an aggregate view in terms of management and bringing in the idea of observability as a key aspect of the way that you're going to do your monitoring. And with that, what I'm going to do now is I'm going to ask you folks to please participate. We have a poll that we're going to start here, and I want to quickly go through what it is we're asking, and then Kim's going to come back and talk about the results of the poll later. But the first thing we want to ask is, which of the following do you recognize in what you've seen as being inhibitors to cloud native adoption? Now, this could be one of many, or many of many, so choose as many as you like. Is the problem that you've seen that's really inhibiting you from getting to cloud native being attempting to just lift and shift the old way of doing things with minimal refactoring? Is it going the other direction and breaking up your solution into way too many overly fine-grained pieces? Or is it just kind of uncertainty around how you handle state and stateful components? Is it that you're over-focusing on this idea of elastic scaling when really other things like resilience and agility may be important or more important for you to be able to meet your business and IT needs? Or is it forcing agile methods into what is fundamentally a waterfall process in your organization, meaning you may not have the skills or the organization to be able to take advantage of that? And with that, like I said, you can all start with the poll and start answering questions. And I'm going to turn things over to Kim, who's going to now begin to walk through our breakdown.
Thanks very much, Kyle. And you described very well how we came up with this sort of grouping. And it really was the way we saw customers talking about these things. They always had a pretty good idea that cloud native was something about containers and microservices. And so the first thing they started diving into was, okay, so what does container technology really look like? And so if we look inside that, really one way of describing what container technology is bringing is that it's lowering the cost of entry of building that first function out, rather than having to try and build a whole environment in a traditional way on bare metal or virtual machines. You're enabling the ability to elastically create things in a container environment. And obviously coming soon after that is going to be a serverless kind of environment too. But the thing that we've noted on this chart as clearly as we could is the fact that there's a big gap between virtual machines and containers. So there's a very, very big difference between those two. And really, what is it? You could do a lift and shift from bare metal into virtual machines, but from virtual machines into containers, there's some big architectural steps you've got to do to take advantage of that environment. And that's really what happens when we start talking about microservices architecture, because those are the architectural precepts that make your application different. So fine-grained is one of those aspects. Obviously, the clue is in the name, right? Microservices. You're making things more fine-grained. We'll talk in a minute about how fine-grained, perhaps. And that allows you to have more agility in the way that you can build those out, perhaps make them more scalable, perhaps change them on a faster life cycle. Being able to decouple things, Kyle's already talking about, if you've broken things genuinely into separate network components, they can now only communicate over APIs and potentially events. That gives us some decoupling, again, around this clear deployment model, minimizing the state and pushing the state further down the stack so that only the things that really need state have it, improves our ability to do the elastic scaling. And then the immutable deployment sitting at the end there is really saying, how can I be really consistent across environments? Can I build up a container that's got pieces of the operating system and the configuration as sort of almost an infrastructure as code, and then the code of the application itself as part of the image, and deploy that? And that works because we now have much more lightweight runtimes that can be rolled out and deployed by the container environment. So that's a really very different way of looking at things. But so far, we've only looked at containers and microservices. And that's only the sort of the beginning, if you like, of what cloud native really is. Where it starts to get more challenging, the adoption hurdle, if you like, is around how do we automate things? How do we automate the continuous integration delivery methods that are going to get us to the point where we can more quickly deploy things in that way? How can we shift things left in that build cycle so that we can have more happening in the earlier stages to ensure that when things go out into production, we're not having to deal with issues, perhaps even around security and performance, that we would have had to before? We've pushed all of that further left down the cycle. And we've done that because we've been able to get this feedback loop where we get information from the cycle and we push it back as fast as we can into those short iterations within a sprint. And then we're able to push that through the chain. And we're doing that through moving to agile methods. We're doing that through bringing development and operations closer together. So to enable them to have a closer collaboration, perhaps even have the same people. Moving the role of monitoring to that of site reliability engineering, which is more of a role around coding and patternizing the way that we handle issues in production. And then underlying all of that is this idea of automating everything, automate the life cycle, CI/CD, even continuous adoption. So that's making the runtimes up to date as well. And then finally, operational automation, and using things like, the built-in operators, for example, in Kubernetes environments, to enable them to automate the way that things are deployed in a more sophisticated way, and build things so that we can really supply things as infrastructure, as code that describes the to-be model. This is how I want it to look, rather than having to actually configure a topology and let the underlying environment do the hard work for you. Now, this is a good time to step back and have a look at the poll results. So I'm just going to go back and take a look at that here and see what's come through. And that's quite balanced, actually. I was expecting it to be really pushing in one direction. Of course, I'll have to admit that, we've only given you 5 answers, and I bet there's loads of you are saying, I've got another one. But these are the ones that jump out at us as being really common. I see that sort of lift and shift, just lifting and shifting into containers, that causes lots of challenges, because you really need to think about a different way of architecting things. We talked about that with microservice architecture. The stateful issue is clearly coming through as a really key one, and it's just a big open question, isn't it? It's always been, in any decade I've been involved in IT, how do I handle state is always a very different problem to how I handle the nice, simple, relatively simple logic that I have on top of that. Forcing agile methods into a waterfall process, again, we've got that issue of, not everything is going to be suited to agile. Many things can do a flavor of agile. Some things are fundamentally more waterfall in nature, and they have different periodicity, if you like. So those are clearly coming out as the high ones, but we've got to vote for everything. So, the other things too. I know Carl wrote a blog recently on the idea of elastic scaling not necessarily being the highest priority, and that's the one in red shown there, that, resilience and agility might be just as important. And then going too fine-grained is, there's probably books written on that from a microservices perspective. So thank you for that. That was useful to have a look at what people saw as the key things. We've got a pretty good balance across them. Let's finish then with a dip into these success factors, as we call them. So if you start to do cloud native across the whole organization, at scale, if you like, what are the things that really start to have an effect on you there? And the sustainably empowered aspect is really saying, okay, so cloud native is allowing us to give teams more autonomy. It's allowing them to provision things they perhaps couldn't easily provision before. We've automated so much. We've made it possible for people who perhaps wouldn't have been able to operate this particular piece of technology before. Now they can. Okay, so we've given that opportunity for, if you like, decentralizing and federating out work to other teams. But how do we govern that? How do we control that? And we see a lot of this in certainly microservices teams getting together in guilds and discussing ways of harvesting the best practices that they've found, rather than having a sort of top-down ivory tower governance, having it the other way around as more of a sort of community-based harvesting of best practices, and trying to find ways to govern in the large, if you like. Security by default. Zero trust is the buzzword at the moment, but there's lots of things that sit behind that. Things like threat modeling. So really this is saying, okay, so you have perimeters like firewalls, you have DMZs and so on, but we can no longer assume that that's a barrier. People will get through those. We know they do. We know from history that they do. We know there will be people on the inside. We know code will get inside your containers that's from perhaps a malicious source. We know humans make errors. It happens all the time. And so we have to assume no trust in anything. We have to verify the identity of things. There's a phrase that says identity is the new perimeter, which is quite a nice way of looking at it. So one way is to say I'm going to verify the identity at all levels, and using some of that shifting left to shift left the security side as well. So the secure by default is another key thing, and then finally managing in aggregates. As we look at the complete set, the complete set of many, many more components that we're going to see out there if we've gone to a more fine-grained architecture, we need to recognize that, if Kubernetes is looking after a set of containers for us, it's going to be growing them elastically and equally killing them off on our behalf on a regular basis. We're not going to be able to trust the idea of monitoring from the inside. We've got to look at it, observe it from the outside. We've got to look at the logs and the traces and start to work out what's going on the inside from the outside. And that means aggregating logs from many different sources. And that also means perhaps introducing things like AI into the picture to help us handle this rich amount of unstructured and structured logging, and also relating that to the resolutions and problems that we've seen in the past and the tickets, and bringing those together to help us to be more predictive as well about how we manage the infrastructure. It's a much more complex environment. So that brings us through all of those ingredients. Here's the infographic, or maybe the second infographic that we've come to today, that sort of shows you all of those things. And of course, the blog series goes into much more detail. I did deliberately collect together a set of examples of the cloud native adoption challenges here. We've kind of talked through these because I deliberately asked poll questions that relate to these, but you can see all those same issues coming in there. What happened where around the observability issues, waterfalls. Some waterfalls are beautiful. Yeah, not everything is going to be agile and so on. But these are the kind of things that are barriers to adoption. But at the same time, if you know that in advance, then you can work on that. Now we've got a few minutes left. I don't know if we've got any good Q&A that Carl, you may have been having a look at what we've had coming through the Q&A. Is there anything we'd like to answer at this point?
Yes, we do. We have one, which is, let's use the seed question here. Cloud native is clearly just one way of embracing the cloud. Could you comment on other forms of migration to cloud? You want to start with that one, Kim, and I'll move on to the next one? Or move on to...
Well, yeah, I mean, in that one, I think the cloud native is only one way of going onto the cloud. Clearly, there's a lot of other aspects to it. As we mentioned, you could be using cloud infrastructure, you could be using different styles. I think actually one of the best recent sources is a piece of work you've been doing yourself, Kyle, recently on this. I saw it come up on LinkedIn. So on the cloud native patterns, which talks about the framework, if you like, of the patterns in cloud. So that would be a good source to go and have a look at.
Yeah, because what we see is that moving to cloud native is a journey. You can't get there in one step. I mean, hopefully we've been clear on that today. But one of the best places to start out, for instance, in many clients, is beginning with just like containerizing the monolith, if you can, for small monoliths. That will get you experience in the container approach and some of the DevOps approaches. And then you can begin to break it down into microservices and really just start down that path and that journey that we've begun to describe. And there are, other options we can take too. But again, the cloud adoption patterns is a great way to look at that. Okay.
Sure. Just skimming through the other questions, I think there's some nice compliments in there, which is great. Also, someone mentioning, where do we see AI and machine learning fitting into this broader picture? I've mentioned one around the aggregation, but of course there's lots of places. Go ahead, Carl.
Yeah, there are. And so one of them that I see AI and ML having a big impact on is in the operations side, because here's what we've just talked about. We've talked about observability and being able to do things like aggregating your logs together and look at things from the outside. Well, if you start to think about that set of logs and events and other things as being a stream of data, well, you can take that historic stream and you can use it to train AI models. And that once you've trained those AI models, now the AI model can tell you what to look out for that may be indicating that you have a problem coming along. And so AI ops is one really big area that I see this, really coming up and being important with. Another one that I also see is if you start to break things apart as a microservices approach and you start to break them up into connecting them with an event streams type of approach that you and I have talked about before, that again becomes an opportunity to look at those historic streams of data that are passing between the microservices and use that to train AI and ML models for things like fraud detection and things like that. So absolutely, it fits into this very, very well once you start looking at the data in a slightly different way. Okay. There is another one here. When moving applications to microservices that involve process orchestration, who's responsible for this in the new world? You want to comment on that one, Kim?
Yeah, sure. And I think so. Part of my background is in BPM as well as integration and other things, and it sort of lies across all of these. Really, we see an increase in use of what's actually a very old pattern, the Saga pattern. It's multiple decades old, in fact, that one. And the question, I guess, is saying, well, yeah, who owns that? Because that's stateful, right? So who's going to own that state if you're making changes across multiple different microservice components? Who's going to hold that all together? And, it's difficult to answer this in a short way, but I think the key point is that people have definitely moved away from two-phase commit transactions across the boundaries, big boundaries within the organization, and they're moving towards a more eventually consistent model, and recognizing it as something that, the problems that two-phase commit can bring stop the scaling, they make disaster recovery more difficult, and so on. And so a more eventually consistent model is more common. But there's so much more I could talk about on that topic, but I think we're running out of time.
I think we are too, and that may be worth its own talk, actually. It's just,
that's true.
BPM and the Saga pattern, and when to use two-phase commit and when to use not to use two-phase commit is, I think, its own topic. So
yeah.
Anyway, I do believe we're probably to the end of our time. So Jessica, if we want to wrap, I think now's a good time to do that.
Awesome. Fantastic, gentlemen. If you have any additional questions, there'll be a link there to the IBM community where you can connect with Kyle and Kim directly. I just want to thank everyone who could join us around the globe today. That concludes today's webinar. We hope everybody has a great day. Thanks so much.
Thank you, Jessica. Thanks for everyone for joining.